Today we're going to be working on problem 2 from the midterm, but instead of left-hand circular polarization, we have right-hand circular polarization. The question states a 1592 megahertz right-hand circularly polarized electromagnetic wave is observed to have a magnetic field strength of 5 milliamps per meter along the y direction at the origin when t equals 0. The wave vector is given by this equation. Find the full time domain expression of the E field. So for the full time domain expression, we're going to have two parts because the wave is circularly polarized. So for the first part, we'll find omega, and omega equals 2 pi times the frequency, and we're given the frequency to be 1592 megahertz. So that equals 2 times pi times 1592 times 10 to the power of 6, which gives us 1 times 10 to the 10, or 10 to the 10. And next, we want to figure out our K, or our magnitude. So that is given by the equation K naught equals the square root of 40 squared plus 30 squared, which equals square root of 2500, which gives us 50. And since we have K and omega, we can now figure out what our N is. And our N is our index of refraction, and we're trying to figure out if that's 1, because if it is, then we know that our wave is traveling through air. So using the equations, omega over K naught equals V, we know that V equals C, which is the speed of light, over N, which is the index of refraction, which we're trying to figure out. So manipulating the equation, we get N equals C times K naught over omega, which is simply 3 times 10 to the 8, which is the speed of light, times K naught, which is 50, over omega, which is 10 to the power of 10, which gives us 1.5. And since this is not equal to 1, we know that the wave is not traveling in air. So in the future, when we figure out our eta, is not going to be 377, it's going to be 377 divided by this number over here. Now, we can draw our axis, and over here, I'm going to choose this to be my x-axis and this to be my z-axis, because we're given x and z as our wave vector, so it'll just be easier to use the x and z axis. And using the right hand rule for axes, if we think our right thumb to be our x-axis, our index finger pointing up to be our y-axis, and our middle finger pointing towards us to be our z-axis. If we move our hand so that the z is pointing up, and which is our middle finger, and x is still pointing to the right, we see that our index finger, which is our y-axis, our positive y-axis, is pointing into the board. So in that case, we know that our y is pointing into the board. And since in the question it says our h is along the y direction, we also know that our h is also going into the board. And now, to figure out which quadrant our E1 vector is in, we have to first draw our K vector, which is given by this equation right here. So 40x and negative 30z. So positive is x is going to be over here, and negative z is going to be this way. So draw this and say this is our k. And we said that this, the x over here is going to be 40, and the z is 30, which gives us, which is 40 over 30, which gives us a 4:3 ratio. And to figure out which quadrant E1 vector is in, we use the right-hand rule. And what the right-hand rule says is our K is our right thumb, and our H is our curled fingers of our right hand. And if we point our right thumb in the direction of K and we straighten out our curled fingers from, because our H is into the board, so fingers are going to be pointing into the board while our right thumb is pointing towards K. If we straighten out our fingers, we see that our fingers point in third quadrant, so E will be in this quadrant, the third quadrant, and our E is, since our K has a 4:3 ratio, our E1 is going to be the opposite of that, so it's going to be 3:4 ratio. So it's going to be 3x and negative 4z. So this is 3 or 30, and this is 40 because 3:4 ratio. And next, we need to find out our magnitude of E0, which is given by the equation E0 over H0 equals eta. And we know that eta equals eta naught over n. And we calculated n earlier to be 1.5. And we know our eta naught in air is 377. And when you divide those two numbers, you get 251.33. So plug that into this equation again. H naught equals 251.33. And E naught equals 251.33 times H naught. And we know our H naught is 5 because of this right there, because it says the strength of our H field is 5. So E naught equals 251.33 times 5 equals 1,256.67. And forgot to label E1. So our E1 is going to be the direction first, which is 30 negative 30 x hat minus 40 z hat. But we have to normalize that. So that's why we divide by 50. Times E naught, which is 1,256.67. And because t equals 0, when t equals 0, we're getting a non-zero. So that's how we know it's a cosine function. Cosine times omega t, and we calculated our omega to be 10 to the 10. So 10 to the 10 t. And then we plug our k back in the wave vector equation back into here. But since this is positive, it's going to be a negative here, so it's going to be negative 40x plus 30z. So that's our E1. To figure out E2, we draw a vector, our axis again. Again, we label it X and Z for the reasons explained earlier. Y is positive, Y is into the board. H is also into the board. We have our K vector here. E1 here. And since the wave is right-hand circular polarization, we use our right hand. And same thing as before, our K is our right thumb. And our finger straight out of our right hand is going to be our E1. And if we point our right thumb in the direction of K and our right finger straight out in the direction of E1, when we curl our fingers, we see that the fingers point into the page. So that tells us that E2 is also into the page, which is in the positive Y direction. Therefore, our E2 equals positive Y hat times the magnitude of E0, and it's 90 degrees in phase with our E1, which is cosine, so it's going to be sine. And again, omega t, which is 10 to the 10t, and copy the rest, 40x plus 30z. So our full time domain expression is going to be E equals negative 30x minus 40z hat, an x hat, over 50 times 1256.67 cosine 10 to the 10t minus 40x plus 30z plus, because positive y hat, times 1256.67 sine 10 to the 10t minus 40x plus 30z. And since originally it was milliamps, so it's going to be millivolts per meter. And just to clarify a couple things, we know our K is the opposite signs of what we were given originally over here, because the original wave equation is cosine or sine omega t minus k dot r. So since we were given k as positive 40x minus 30z, when you plug it into here, it becomes negative 40x plus 30z. As for our ratio here, we know the angle between these two is 90 degrees, and this is our alpha. So tangent of alpha, and we know tangent of alpha, tangent is opposite over adjacent, so the opposite is 30 and adjacent is 40, so that's 3 to 4. So this should actually be a 3 to 4 ratio. And let's make this a little clearer. The angle between these two is also 90, so therefore this is alpha, and tangent of alpha again is opposite over adjacent, so 30 over 40, which is 3 over 4, so this is going to be 3 or 30, and this is going to be 40 or 4.